Imagine a car driving on a convex bridge, which is like a big curve. As the car moves along the curve, it needs to feel a force that keeps it on the circular path. This force is called centripetal force. When the car is on a flat surface, there are two forces acting on it: the weight of the car, pulling it down, and the normal force from the road, pushing it up. These forces cancel each other out, so the car doesn't feel any force in the vertical direction. But when the car is on the uphill part of the convex bridge, things change. The weight of the car is still pulling it down, but the normal force from the bridge is perpendicular to the surface. We can break down the weight into two parts: one part that's opposite to the normal force, and another part that's perpendicular to it. The perpendicular part of the weight creates an opposing force that slows down the car, so the driver needs to accelerate to keep it moving in forward direction. The part of the force that is opposite to the normal force is greater than normal force. Hence, it cancels out the normal force, and the remaining force acts towards the center and along the radius. This force is what keeps the car on the circular path, and it's the centripetal force. When the car reaches the top of the convex bridge, it's pressing down on the surface with a force that's less than its full weight. This means the car gets a smaller normal force from the bridge, which is then canceled out by the weight. The result is a small net force that points downwards, providing the centripetal force the car needs to move on the curve at the top of the bridge. When the car is on the downhill part of the convex bridge, the weight is still pulling it down, and the normal force from the bridge is perpendicular to the surface. The weight can be broken down into two parts: a horizontal part that's parallel to the road, and a vertical part that's perpendicular to it. The horizontal part accelerates the car downhill. The vertical part of the weight cancels out the normal force from the bridge, leaving a small remaining force that points towards the center of the curve. This remaining force is the centripetal force, which keeps the car on the circular path. So, in short, the car's weight is helping it accelerate downhill, while also providing the centripetal force it needs to stay on the curve.